Okay, today we're going to cover two topics, 9.1, inverse variation, and 9.2, graphing inverse variations. Your objectives today are to use inverse variations and combine variations. In conjunction with this, we're also going to review some of the direct variations that we've talked about earlier in the first semester. You can pause the screen anytime you need to. You can tell the substitute to pause it, or you can pause it yourself if you're on the laptops. Remember, a direct variation is in the form y equals k times x. This means there's some constant k multiplied by the variable x. So as y scales up, x will scale up, or as x scales up, y will scale up. For a direct variation, if you solve for k, that's dividing both sides by x, you're going to get k equals y over x. So when we solve for k, it looks like a fraction. When we solve for y, it looks like a multiple. Now for an inverse variation, its y is some constant k divided by x. Or if you solve for k, k equals x times y. This means that when y goes up, x is going to go down. Remember that k, x, and y cannot equal 0, or you don't have a variation at all. Okay, now here's an example. You don't need to copy this if you have it on your slide notes, so you can just look at it. But this is an inverse variation example. So if you were flying in a plane to Milan for a fashion show, and you want to know how long you're going to be in the air, what you would want to do is take the distance between your destination and your origin point and divide it by your speed. So let's say it's 4,413 miles from Hampton to Milan, Italy. And let's say that your plane can cruise anywhere between 100 and 600 miles per hour. 100 is more like Cessna speed, 600 is more like jet speed. So what I did is I said distance is rate times time, or distance over rate will equal time. So if we had a 100 mile per hour rate, we would divide 4,413 by 100 miles per hour, and we would get 44 hours, 0.15. If we did 200, we would say 4,413 divided by 200, we get 22 hours. And this makes sense. Wouldn't it be about half as much time if we went twice as fast? And so on. So you can see that all the way down to 600 miles per hour, our trip is only going to take about 7.3 hours to get there. Okay, so as one variable goes up, the other variable goes down. All right, let's see what that looks like on graph. Okay, here is our 100 mile per hour trip, and here's our 44 hours. Here's our 200 mile per hour trip, and here's our 22 hours, and so on. And this is what an inverse variation graph will look like. Again, if you want to pause it and sketch it very quickly, you may. All right, so some of your homework will ask you to check to see if you have a direct variation or an inverse variation, or neither. Now, if you have a direct variation, remember it is y equals k times x, or the constant k would be y over x. So if you're dealing with an x and a y table, you can solve for k. If it's an inverse variation, remember that's y equals k divided by x, or your constant is x times y. So what we want to do is set up two additional columns. And we want to do both multiplying x times y or dividing y over x to see which one gives us a constant. And so when you multiply 0.5 times 1.5, you're going to get 0.75. When you multiply 2 times 6, you get 12. When you multiply 6 times 18, you get 108. So because the k in this column is not the same all the way through, we know it's not this kind of variation or inverse. Let's try direct. If we divide y over x, 1.5 over 0.5, that gives us 3. 6 over 2, that also gives us 3, and 18 over 6 gives us 3. So this is the type of variation we have. And that means we are dealing here with a direct variation because the constant was y over x. Now what happens if neither column has the same number all the way through? Would it be direct or inverse? No, it would be neither. Let's try another one. Now I have my x values are 0.2, 0.6, and 1.2, and my y values are 12, 4, and 2. So this time when I multiply the two, 0.2 times 12, I get 2.4. 0.6 times 4, same. 1.2 times 2, same. Now, because k equals x times y, I know I have an inverse variation. And you can check the directs column, and they won't be the same. Now, there's an example on page 479 that I particularly like because it's a real-world example. And take some time to read it. I'm not going to go over that here, but it's very interesting that the quicker your heart beats, the shorter your lifespan. So because one here goes down and the other goes up, we know that this is an inverse variation in nature. All right, when we combine variations, we can do both direct and inverse together depending on where the variable falls. So for instance, if you had y varies, that's what the equals is, with two variables, z and x, k is the constant, so it never varies with k. Now because z is in the numerator, we're going to say y varies directly with z, and because x is in the denominator, we say it varies inversely with x. So it's read y varies directly with z and inversely with x. Same thing here. Y varies. The y equals would always be read as y varies. The constant you don't sound out. You leave the constant alone, but you do read out the variables that are other than the constant. So we're going to say inversely with the cube of x because x cubed is in the denominator. So y varies inversely with the cube of x. Now for this example, y varies. Well, what are we going to say for the x squared? This is now in the numerator. We're going to say directly with x squared and inversely with w. Notice we never read out k. K is the constant. If you have two direct variation variables, the x and the z, we call that joint variation. We call it y varies jointly with x and z. However, when the two are in the denominator, we don't say jointly. Jointly is only for direct variations. If you have w and q in the denominator, you would say y varies directly with x, because x is in the numerator, and inversely with the product of w and q. Okay. You may have to write a variation depending on the words. So, if you had the words y varies inversely with the product of x and w and directly with the square of z, you would start with y varies, or y equals. Inversely goes in the denominator, so the product of x and w goes down here, and directly with the square of z goes up here. K must be a part of the formula, but you notice there was no mention of k up in the words. And I'll let you try these three on your own. Okay, now to graph inverse variations, I want your calculators out and on, and I want you to be in the equation editor. So, first thing I want you to do is go to the y1 equals key and type in 4 divided by x and graph it. Okay. And if you're looking at the same thing I am, you'll see two branches. This is what an inverse variation truly looks like. There will be two branches. They will either be in quadrants 1 and 3 or 2 and 4. Okay, and you can set up a table to look like that.
Do you know what PC5 is?
Right next door.
Okay, thank you.
All right, sorry about that. Just had a knock on my door. All right, now what I want you to do is go back into your calculators and try y equals -4 over x. And I'm just going to turn my formula on because I already had it in there. And now look where our branches go. Now for the negative k values, you get branches in quadrants 2 and 4. All right. So for 4 over x, we got this graph. And for -4 over x, we got this graph. Okay. Now, when you're sketching these, the thing I want you to know is they will always look like branches, but there will always be a point where it's closest to the origin. And I've actually misgraphed these because if you were to take the square root of k, remember k is 4, if you were to take the square root of k, you're going to get the point that's closest to the origin. So it's actually going to be over 2 and up 2. So this graph would actually be drawn like this. It has to go through that point. So what happens if you turn your k value into a 9? All right? So y equals 4 over x. You're going to take the square root of 4, and that's 2. Y equals 9 over x. The square root of 9 is 3. So that point would come out 3 and up 3, and your branch would do something more like this. So you can see as k gets bigger, your branches come further away from the origin. So you should be able to do these at home without a graphing calculator because you're just basically throwing up a branch and putting in the point closest to the origin. Alrighty, so let me clean this up a little bit. So what we have is a translation of an inverse variation looks like y equals k divided by x minus b plus c. All right, so let me put some real numbers in there. If I let 4 be k and 6 be b and 5 be c, this tells us some interesting things about the graph. It's no longer going to be centered about the origin. It's going to move away from the origin. And what it does is it moves up 5 units. So you can see I went up 1, 2, 3, 4, 5 units, and I drew an asymptote. It's a horizontal asymptote through the line y equals 5. But then I also had to draw an asymptote at a positive 6. Now here's how you find the x-axis asymptote. You've set this piece of the equation, this denominator, equal to 0. So if I let x minus 6 equal 0, x would have to be positive 6. And you can see I drew an asymptote at the positive 6. And now I'm back to just drawing the branches. Okay? So you'll have two asymptotes, an x-axis asymptote and a y-axis asymptote. The y-axis asymptote is always this number right here, and the x-axis asymptote is always this number right here, but opposite sign. All right? And so if I were to ask you to write an equation of the translation of y equals 7 over x that has asymptotes at x equals negative 2 and y equals 8. All right? So if x equals negative 2, that's your b value, and if y equals 8, that's your c value. So you're basically going to plug those in to your b's and your c's. So negative 2 goes here, 8 goes here, and remember when you have minus a negative, that turns into a positive. So your new equation would be y equals 7 over quantity x plus 2 plus 8. I know there's homework here somewhere. All right, so your homework is page 481. Do problems 1 through 3, and this is on the board, 7 through 11, and 13 through 26. And that's all problems. Then you're going to go to page 488, and you're going to do problems 1 through 3, 15 to 21 odd, and 28 to 30. Okay, so please take out your books and begin your homework now. Thank you.